Okay, so, sorry about that, guys. Hopefully it works. Let me go ahead and go over here. So, first we're gonna have to look at, some, examples. So basically, this is 1.3. I'm doing this in order to, so I already did composition of functions. If you guys want to look at that on my live stream, y'all can. I also have videos on that, or that live stream specifically. I do have that available. So basically, what I want to do is I want to go ahead and do a live stream where, and give me a second, guys. So I basically want to do this video to help people understand the like radicals and rational exponents. So here we have an example about the Pythagorean theorem. So if you remember from like high school or middle school, you learned about the Pythagorean theorem back in like maybe, I want to say maybe 8th grade or so, or 7th grade, or even 6th grade. It basically says a squared plus b squared equals c squared. So, you know, this part here is a, this part here is b, and this part here is c, and they're just solving for c, right? This is the radical, so the radical is like the square root sign. The radicand is what's inside the radical, and the radical expression is what's whatever, you know, it's the whole thing, right? Give me a second, everybody. Sorry. Okay, sorry about that, everybody. Also, I'm trying to like make my make this a little bit more centered, if I can. So, okay, so let's move on to what we were doing. So, so here we are evaluating square roots. if we are doing expressions, you know, like radical expressions, for now we're gonna say that the radical expression is equal to the positive square root. So like whatever radical expression we have, that is the positive square root of that. So basically, the square root of 100, for example, we know that that's 10, right? The square root of 16, so like the square root, actually, hold on. So like the square root of the square root of 16 is really the square root of whatever the square root of 16 is, which is, you know, so basically the way that I do it is the square root of the square root of 16, which is equal to the square root of 4, which is equal to 2, right? So that is how you do that, right? Now, what about, so let's see here. Give me a second, guys. What about the square root of 25 plus 144? So, the square root 25 plus 144, that's equal to the square root, so it's going to be, you're just adding them, right? 144 plus 25, that's 169, so it's the square root of 169. If you know your squares, so like 13 times 13, if you can do that, and if you multiply it, it'll literally give you 169, so you can see that this is equal to 13, right? So, so then, sorry guys, give me a second. Give me a second, everybody. I'll be right back. Okay, sorry about that, everybody. So, basically, yes, so the square root of 169 is 13. So that's how you do that one. If I go to the next one, the square root of 49 minus the square root of 81, that should be, so we know that the square root, so the square root of 49 minus the square root of 81, that should be, so the square root of 49, we all should know that's 7. Square root of 81 is 9. So if you should know your times tables for this. So 7 minus 9, that should be negative 2. So the square root of 49 minus the square root of 81 is negative 2. Okay. Oops. Sorry, guys. So, moving on to the next one. So as you can see, it's 13, right? And we can even show the solution for each one of these. Sorry, guys. So, yes, so the square root of 100, that should be 10 because 10 squared is 10, right? So that's something that we should all know, right? That's something that we should all understand. Sorry guys, give me a second. I lost exactly where I was. Okay, my bad guys, I lost exactly where I was. Oh my goodness gracious. Okay, so let's just move on to the next one. I don't know where did I put it? Sorry everybody. Give me 1 second. So, I feel like it's a lot better if I do it this way on here. On OneNote instead. I mean on not OneNote, Microsoft Edge. So, Sorry guys, give it a second. So okay, so yeah, as you can see, all the ones that we did so far, you can see that it's 7 minus 9 equals -2, right? So here's the thing about Q&A. For the square root of 25 plus 144, can we find the square roots before adding? So no, you can't do that. So here's the thing. If I say the square root of 4 plus 9, this is not equal to the square root of 4 plus the square root of 9. The formula goes like this. The square root of a plus b does not equal the square root of a plus the square root of b. There's a reason for this, because the square root of 4 plus 9 equals the square root of 13, and the square root of 4 plus the square root of 9 is actually 2 plus 3, 5, which means that 5 does not equal 13, right? Okay, so sorry about that. So basically, so now we're going to evaluate each expression, right? So, or actually, let's just move on to the next example, because that way we can check our answers and we don't have to do anything else. So we need to use the product rule to simplify these square roots, right? Here's the thing about doing these. You can do these two ways. You can find your perfect squares, or you can do it by, so I'll just go ahead and do it. I'll show you guys how to do them. So the square root of 300, for example, we can do a factor tree. So we have the square root of 100. So we have 100 times 3. Looking at the square root of 100, we know that this is 10. The square root of 3 cannot be simplified. So this equals the square root of 100 times 3, which equals the square root of 100 times the square root of 3, which equals 10 square root 3. Okay. Later on, you will have to do plus or minus, but for now, we're gonna just do the positive. Okay. So what about the square root of 162, a to the 5th, b to the 4th? So this one is a little tricky one. Let me first start by saying the square root of 100, a squared, b squared, because I feel like that's a little less problematic. So first of all, we should know that the square root of a squared equals the square root of a, times the square root of a. Which means that this is the square root of a quantity squared, which means that it's a, right? So this is the square root of 100 times the square root of a squared times the square root of b squared, which is 10 times a times b. So this should be 10 AB. Now, looking at the one that we have, what if we have 100 a cubed b squared? So it's the same idea. When we do the square root, it's the same idea. But we have the square root of 100. We're going to simplify a cubed as a squared times a. And then we're going to say times the square root of b squared. This is 10. This means that we have the square root of a squared times the square root of a times b. So this should be 10 a square root of a times b. So this should be 10. Sorry, guys. It should be 10 AB square root of a. You can also write it in exponent form if you want, but you don't have to. It just depends. I don't think you have to. But the one that we're looking at is 162 a to the 5th b to the 4th. So 162 a to the 5th b to the 4th. We know that b to the 4th equals b squared times b squared. So the square root of b to the 4th, if you know the form, the nth root of a to the m. So let me write it this way. There's a form that's called the nth root of a raised to the m power. This is a raised to the m over n power. So that means that the square root of b to the 4th equals b raised to the 4 divided by 2 power, which means b to the 2nd power, which means b squared. So this actually turns into b squared. This is why we must remember this, guys. This is really, really important. So what about 162 though? 162, I don't think we can simplify it any further. Unless we do, so we're going to do 1 squared equals 1, 2 squared equals 2, or sorry, 4. 3 squared equals 9. 4 squared equals 16. 5 squared equals 25. So we're going to see if it's divisible by 9. If we do 9, we have 72. So then 9 times 18, right? This is 9 times 18. This one is 9 times 2, right? So in reality, the square root of 162 equals the square root of 9 times the square root of 9 times the square root of 2, which is 3 times 3 times the square root of 2. In reality, that's what it is. The square root of 162 equals the square root of 9 times 9 times 2, which you split it up into 3 square roots. this means that we have 9 square root 2, right? So we look at that and we say, okay, well, we say 9 square root 2 for just this part. So the square root of 162 is 9 square root 2. What about the square root of a to the 5th? If we have the square root of a to the 5th, just like I said, this is equal to the square root of a to the 4th times a, which equals the square root of a to the 4th times the square root of a, which again, like I said, the square root of a to the 4th equals a. It's really square root like this, a to the 4 over 2, which is a squared. So this simplifies to a squared square root of a. So this becomes 9 square root 2 times a squared square root of a. This becomes 9a squared square root of 2a. I believe that's what it is. And then b squared. Because b squared, we said the square root of b to the 4th is b squared. Right? So we know the square root of b to the 4th, we know that's b squared. So we need to put 9a squared b squared times the square root of 2a. Okay? I really hope that makes sense. I'm doing my best to explain it. If anybody's confused, let me know. Okay, so so for this one, yes, it was 9a squared b squared times the square root of 2a. Right? This one is a tricky one. Part B. Okay, so now simplify, or actually let's move on to the next one. So simplify the radical expression. The square root of 12 times the square root of 3, right? The square root of 12 can be simplified as 4, so it's 4 times 3, right? This can be simplified as the square root of 4 times 3, which is the square root of 4 times the square root of 3. Remember, the square root of AB is equal to the square root of A times the square root of B. Okay? So this becomes 2 square root 3, right? So 2 square root 3, that's basically what it is, right? Let me... So now there's something else called the quotient rule for square roots. So basically, what you're gonna do, so it's the same thing as the first part. So basically, the square root of a over the square root of b. So actually, hold on. The square root of a over b equals the square root of a over the square root of b. Okay, that's another thing that we must remember in algebra. It's a very common rule. So, this is the quotient rule for square roots. So we must know what this is. So like, for example, the first one, or example 4, the square root of 5 over the square root of 36. We said that 6 squared is 6 times 6, which is 36, right? So that means the square root of 36 equals 6. So this simplifies to the square root of 5 over 6, right? What about the square root of 2x squared over the square root of 9y to the 4th, right? So this one actually becomes, so we have the square root of 2x squared over the square root of 9y to the 4th. This becomes the square root of 2 times the square root of x squared over the square root of 9 times the square root of y to the 4th. Remember that y squared times y squared equals y to the 2 plus 2 power, which equals y to the 4th. If you don't know that, you can always say the square root of y times the square root of y. Or actually, remember the square root of y to the 4th equals the square root, or I'm sorry, equals y to the 4 over 2 power. So that means that this equals y squared, right? Because the nth root of a to the m equals a to the m over n power, right? So this becomes x square root of 2 over 3 y squared. Okay. Example 5, so simplify the radical expression. So this is a big number, 234 x to the 11th y. So the square root of 234 x to the 11th y divided by the square root of 26 x to the 7th y. Right? So basically, we can do two things. So we can either take the square root of 234, or we can try to simplify. We can make it like this. So we can say the square root of 234 x to the 11th y over 26 x to the 7th y. Notice that y cancels out, okay? Y cancels out. Remember that the law of exponents, when we have x to the nth power, x to the m, or actually, let me do it this way. X to the a divided by x to the b equals x to the a minus b power. Right? So this becomes 234 square root over 26 times x to the 11 minus 7 power, right? 234 over 26 we can simplify, or we can try to simplify. 234 over 26 is 9. So this becomes 9. So the square root of 9 times x to the 4th power, right? Times the square root of x to the 4th power. This is the square root of 9 times the square root of x to the 4th power, which is 3 times x squared. So this becomes 3x squared. Okay? And if we show the solution, as you can see, it simplifies to 9x to the 4th because of 234 over 26, that's 9. X to the 11th over x to the 7th is x to the 4th, and y cancels out, so that this becomes 3x squared. I did it in more detail. So, adding square roots. What about adding square roots, right? Adding square roots is another important, how do I say it? Another important skill of algebra, right? So we must understand how to add square roots. And give me a second, guys. I need to charge my laptop again. So, adding square roots is another thing that we must know how to do. So, so for example, 5 square root 12 plus 2 square root 3. This becomes 5 times the square root of 4 times 3 plus 2 square root 3. This becomes 5 times the square root of 4 times the square root of 3 plus 2 square root 3. This becomes 5 times 2, because that's what square root of 4 is, right? And then times the square root of 3 plus 2 square root 3. This becomes 10 square root 3 plus 2 square root 3, which becomes 12 square root 3. Okay? So that's basically how you simplify that. We must understand how to simplify square roots before we can get into really complicated algebra in forms of arithmetic. What about 5 plus 6 square root 20? Or the square root of 5 plus 6 square root 20. So we can try this one. 5 square root of 5 plus 6 square root 20. This is square root of 5, right? Because we can't do anything with that. This is irrational. Plus 6 times the square root of 5 times 4. This becomes square root of 5 plus 6 times the square root of 5 times the square root of 4. You always want to make sure that you can divide whatever's inside, like the radicand. I think that's what it's called. Whatever is inside the radical, you want to make sure that you can divide it by something you can take the square root of. I divided it by 4. So 5 times 4, right? Square root of 5 plus 6 times the square root of 4 is 2, and then we have square root of 5. So this becomes square root of 5 plus 12 square root 5. This is 1 square root 5 plus 12 square root 5. They both have a square root of 5. So this becomes 13 square root of 5. Right? Okay. Subtracting square roots, okay? So this is another one. So now subtracting square roots, right? So this is another one, right? So 20, we have 20 times the square root of 72, a cubed b to the fourth c minus 14 square root of 8a cubed b to the fourth c. Okay, so they both have a like the exact kind of square root, but like they have the same variables, right? But we have to be careful because so they don't have we have to be careful with this one basically. Because they don't have the exact same square root, so we cannot just say 20 minus 14 yet. We have to simplify the square root on the inside. Okay, so that's a tricky one. They're trying to trick you, thinking that you have to do this. Do not, I repeat, do not subtract the square roots yet. So you have to do this 20 times the square root of 9 times 8, or sorry, 9 times 4, right? Because it's 9 times 8, but it's 9 times 4 times 2, times a squared times a times b to the fourth times c, all square rooted. This one is a very tricky one, guys. So minus 14 times the square root of 8. So again, we can do 4 times 2 for this one. 4 times 2, right? And for 72, I did 9 times 4 times 2, right? So this becomes a squared times a times b to the fourth times c, right? So then we have to simplify it. So 20 times the square root of 9 times the square root of 4 times the square root of 2 times the square root of a squared times the square root of a times the square root of b to the fourth times the square root of c minus 14 times the square root of 4 times the square root of 2 times the square root of a squared times the square root of a times the square root of b to the fourth times the square root of c. This one is very, it's a lengthy one, okay? So this becomes 20, the square root of 9 is 3, the square root of 4 is 2. We have the square root of 2 right here, because we can't simplify it any longer. We have times a, right, times the square root of a. So this is what I'm trying to say, okay? Times b squared, right, times the square root of c minus 14 times 2 times the square root of 2 times a, right, times the square root of a times the square root of b to the fourth, which is b squared, right, because b to the 4 over 2, and then times the square root of c. So now we are left with 20 times 3 times 2, that's 20 times 6 times the square root sorry guys, of 2, we're going to bring all the square roots together. So far we have square root of 2, square root of a, square root of c, right? So we can say the square root of 2ac, right, times a times b squared minus 14 times 2 times the square root of 2, that's going to be 28. Yes, 28 square root of 2, so we're going to say square root of 2, and again, I'm going to do the same thing I did for the other one. So, give me a second, guys. So, I have square root of 2, square root of a, and then I also have the square root of c. So I have 28 square root of 2, right? A, c, and then we're left with times a times b squared, right? And then, so that's basically how you do that. Now 20 times 6 is 120, times the square root of 2ac, ab squared, minus 28 ab squared, times the square root of 2ac. They now have the exact same formula, the exact same term. You can rewrite it as 120 ab squared square root of 2ac minus 28 ab squared square root of 2ac. So now this becomes 120, or sorry, it becomes, we can factor. We can take out an ab squared square root of 2ac times 120 minus 28. This becomes ab squared square root of 2ac times, it's going to be 120 minus 28, which is, give me a second, guys. So this becomes times 92. So this becomes 92 ab squared square root of 2ac. This one is very, 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 very lengthy, okay, guys? So do not feel discouraged if you found this one very hard. It is a very, very lengthy one. And actually, it's supposed to be absolute value of a, because actually the square root of a squared equals absolute value of a. That's why. That's why I got that wrong. So when I did this was supposed to be absolute value. And this one was supposed to be absolute value, I think. I'm not sure. Unless I'm wrong. This one was a very tricky one, guys. Actually, no, not this one. Just the square root of a squared. It's a very tricky one, very, very tricky one. Even I got it wrong. So you have to do, it's supposed to be actually, so let me, oh God. I'm so sorry, guys. Let me try this again. So this is supposed to be 20 times the square root of 36 times the square root of 2 times the absolute value of a, square root of a, times b squared times the square root of c minus 14 times the square root of, so it's going to be times 2 square root 2, because the square root of 4 times the square root of 2 is 2 square root 2, times the square root of a squared, which is absolute value of a, times b squared times the square root of c. So let's see here. It's supposed to be square root of a. So this becomes 20 times 6 times the square root of 2. Square root of 2, it's going to be AC times the absolute value of a, b squared. So if we cross it out as we go along, let me write it this way. So, sorry guys, this one is very, very, very tricky. It is a very tricky one. They really want you to use absolute value. Because if you don't use absolute value, it's going to be wrong. So we have 20. We're going to write down, so times 6 times the square root. We're going to do, first we're going to do all the ones that are not square root. So square root of 2 times the square root. Actually, we're going to do the ones that are square root. So square root of a times square root of c. And then, right, so that's square root of 2. So if we highlight square root of 2, square root of a, square root of c, and then we're left with absolute value of a, b squared, right, minus 14. So we're going to do actually 28 square root 2, square root a, square root c. So we're square root 2, square root a, square root c, and then absolute value of a times b squared. So now we do 120 times the square root of 2ac times the absolute value of a, b squared, minus 28 square root of 2ac, absolute value of a, b squared. So then this becomes 120 minus 28, which is 92. So it should be 92 absolute value of a, b squared, square root of 2ac. This one was a very tricky one, guys. And give me a second while I get some water. Okay, so so this one was a very tricky one. So we're gonna move on to the next one. We're gonna move on to rationalizing denominators because that one took a really long time. So rationalizing denominators is another thing, right? 2 over the square root of 3, for example. We cannot have a denominator on the bottom. So we're going to multiply the top and the bottom by the square root of 3. This gives us 2 over square root of 3 on top and bottom. So, or actually, sorry, you have to multiply by the conjugate. So square root of 3 on top and bottom. It's like, basically, if I have a over square root of b, the rule is you multiply by the square root of b over the square root of b, which will give you the square root of ab over b. So this will be 2 square root 3, or sorry, it would be a square root b over b. My bad. So it's going to be 2 square root 3 over 3. If they give you something like this, this will be, so again, if they give you a over square root of b plus c, you have to multiply by the conjugate, which is going to be square root of b minus c over square root of b minus c, which then you have to do FOIL method. So remember, the square root of a plus b times the square root of a minus b is going to be equal to, so this is going to be a times the square root, so it's going to be a square root b minus ac over b minus c squared. That's what this is going to be. So now we're going to do that same exact thing for this one. And the reason why I'm showing you guys with less complicated examples is so that you guys can understand how to do this. So we have 2 over square root of 3 plus 1. So times the square root of 3 minus 1 over square root of 3 minus 1. At least I believe that's what it is. I could be wrong. Hold on. Actually, guys, let me just make sure. Hold on. So, sorry guys, give me a second. Okay, so, never mind that one. What I'm gonna do actually is this. Hold on. So, I'm gonna rewrite it as this. So when it's like this, when it's a over b plus the square root of c, this is going to be equal to, so it's going to be b minus square root of c over b minus square root of c on top and bottom, which means you have a, b, so it's going to be a times b minus square root of c over b squared minus c. I believe that's what it is. So basically, this becomes 1 minus square root of 3 on top and bottom, which then we say 2 times 1 minus square root of 3 over this 1 plus square root of 3 times 1 minus square root of 3. We do FOIL method. FOIL method is it's a minus b times a plus b is a squared plus ab minus ab minus b squared. This becomes a squared minus b squared, right? So that's why a squared minus b squared equals a plus b times a minus b, right? This is 2 times 1 minus square root of 3 over 1 minus 3. This becomes 2 minus 1, 2 times 1 minus square root of 3 over negative 2. This becomes 1 minus the square root of 3 over negative 1, which is 1 over negative 1 minus the square root of 3 over negative 1, which is negative 1 plus the square root of 3. So that's really what it is. Now, if we have, so, for example, 2 square root 3 times 3 square root 10. So, again, if we have, for example, a square root b over c square root d, we multiply times the square root of d on top and bottom. So anything that is on the bottom of the denominator, you multiply. So, like on the square root. So, for example, 2 square root 3 over 3 square root 10, this becomes, so this is times, and, sorry guys, give me a second. Okay, so, so, this becomes the square root of 10 over the square root of 10. This then becomes 2 square root of 3 times 10 over 3 times 10. The reason is because whenever you say the square root of a times the square root of a, this is just a. Because the square root of a quantity squared is a. So that's why on the bottom, 3 times 10, right? So then this becomes 2 square root 30 over 30. Or actually, we can actually simplify it more. So you can divide top and bottom by 2, and you're going to get square root of 30 over 15, right? So yes. So what about 12 square root 3 over the square root of 2? So that's what I was talking about. Or this is actually another example. So, you're going to do times square root 2 on top and bottom. This becomes 12 square root of 3 times 2 over 2. This becomes 6 square root of 6, right? These I just went over, so I'm not really going to go over them again. Simplifying nth roots. So this is a very tricky thing to do. So we're going to go over the first one, the fifth root of negative 32. You must remember your fifth roots. So like 1 to the 5th, and if you don't, you can always multiply it out. 1 to the 5th is 1. 2 to the 5th is 2 times 2 times 2 times 2 times 2. This is 4 times 4 times 2. This is 16 times 2, which is 32. So 2 to the 5th is 32. That means that the square root, or I'm sorry, the fifth root. Sorry, give me a second, guys. That means that the fifth root of 32 is equal to 2. Now, what about 2 to the negative, or negative 2 to the 5th, right? Negative 2 to the 5th is negative 2 times negative 2 times negative 2 times negative 2 times negative 2. This is 4 times 4 times negative 2. This is 16 times negative 2, which is negative 32. So, in reality, it's just like square roots. If I say the square root of 9 equals 3, that means that 3 squared equals 9. If I say the fifth root of negative 30, or if I say for negative 2 to the 5th equals negative 32, that means that the fifth root of negative 32 is going to be negative 2, right? The fourth root of 4 over fourth root of 120, or 1024. So that one is a little bit trickier. I mean, the fourth root of 4 times the fourth root of 1024. 1024 is actually going to be, so we can do by 2s. So this is 2 times 5, 1, 2, I think. And then, so you kind of need a calculator for this one, because this one is a little bit tricky. Give me a second, guys. So 512 divided by 4 is 128, right? So that's 128. So 4 times 128, and then we have 2 times 2, 64. This then becomes 2 times 32, 2 times 16, 2 times 8, 2 times 2, 2 times 4, and then 2 times 2. So that's what I'm saying. So how many 2's do we have in this function, or in this, not function, in this radical expression? We have 1, 2, 3, 4, 5, 6, 7, 8, 9. So 2 to the 9th power equals 1024. The 4th root of 2 to the 9th power, we don't know what it is. That's actually 2 to the 9 over 4 power. We must remember this rule. A to the m over n equals the nth root of a to the m. That is something that we must remember. You have to say it or write it over and over again until you memorize it. In math, you have to memorize things, just like you have to do in like formulas. You have to memorize formulas. There's no other way to do it. If there is, good for you. I mean, for me, that's how I made it through math, is by memorizing these formulas. So we have the 4th root of 4 times the 4th root of 2 to the 9th. So again, this is actually 4 to the 1/4 times, it's going to be 2 to the 9th raised to the 1/4 power. This is so the thing is, they do not have the same let me see how they do it, because it's really, really tricky. So yeah, you could have actually done it this way. Never mind. I'm making it more complicated than it is. I do apologize, guys. So really, this becomes 4 to the 1/4 times 2 to the 9 over 4. This is actually 2 squared to the 1/4 power times 2 to the 9/4 power. This becomes 2 to the 4th power times 2 to the 9/4 power. This becomes 2 to the 11 over 4 power, which is the 4th root of 2 to the 4th times 2 to the 4th times 2 cubed, which actually becomes the 4th root. It's actually 2 times 2 times the 4th root of 2 cubed, which is 4 times the 4th root of 2 cubed. I think that's what it is, guys. I'm not 100% sure how else to do it. Give me a second, guys. because for some reason it's not telling me the answer. So it's actually 8. The answer is actually 8. Which, yeah, that one is a very tricky one, guys. I don't know if I can do this one. I'll skip it because it's a very, very tricky one. So let's move on. So writing rational exponents as radicals, right? So write 343 to the 2/3 power as a radical and simplify. So the cubed, remember, a to the m over n equals the nth root of a raised to the m, right? This becomes, so it's basically, so 343 to the 2/3 is equal to the cubed root of 343 squared. The cubed root of 343 is actually 7. So this can be the cubed root of 343 squared equals the cubed root of 343 times the cubed root of 343, which is the cubed root of 7, times the cubed root of 7. Or I'm sorry, actually I'm right. Am I right? So actually, I'm sorry. The cubed root of 343 is 7. So it's going to be 7 times 7, which is 7 squared, which is 49. Sorry about that, guys. It's been a while for me for these. So that is mostly it for this section. If you guys have any questions, let me know. I can do my best to answer any questions that anybody has. But yeah, this is how I do. This is this section for this part here. So with that being said, guys, thank you so much for watching. If anybody did watch, thank you so much. And again, if you have any questions, let me know. I'm gonna move on in the next video to section 1.4, which is polynomials. And yeah, so with that being said, guys, thank you so much for watching, and I will see you guys in the next stream. Please like, comment, and or subscribe, and and I will see you guys in the next live stream. So, yeah, thank you guys.